Hello. Hello, ma'am. Can you hear me, ma'am? Hello, ma'am. Ma'am, good afternoon, ma'am.
Thank you. Good afternoon.
Good afternoon, ma'am.
Good afternoon. Uh,
Hello. Ma'am, shall we start, ma'am?
yes, yes, we will start. Do you want
Yes.
to turn on my camera or shall I turn off?
No, ma'am, not necessary. Ma'am, just a second, ma'am.
Yes, ma'am.
Ma'am,
Yes, ma'am. Yes, ma'am.
ma'am, just your show your slide, ma'am.
Okay.
Slide is enough, ma'am.
You are able to see it, ma'am?
Yes, ma'am. Shown, ma'am. Ma'am, let's we start, ma'am.
Yeah, yeah, we will start, ma'am. Shall we start?
Yes, ma'am.
Yes.
No, no, ma'am. I'll introduce you.
Yes,
Then you
yes.
can
I
start.
know, I understand. Yes.
Okay. Good afternoon, everyone. Welcome to the IIC activity on panel discussion with overview of petroleum refining and petrochemical processes. I take this opportunity to welcome today's chief guest, Dr. A. Brindha Lakshmi, an academic expert and also an expert in treatment of industrial effluents, ionic liquids, biofuel production from wastewater, and extraction of bioactive components from waste. She has completed MTech degree in NIT Trichy. Later on, pursued her PhD from Anna University, Chennai. It is an honor and privilege for us, madam, to have you with us today. I also welcome the faculty members and students on and off the dais. I'm sure we will be enriched by the IAC activity lecture. Once again, I welcome all of you for this IAC activity on behalf of Department of Chemical Engineering, Mahendra Engineering College. Now I hand over the session to the guest speaker, Dr. A. Brindha Lakshmi, for her presentation. Thank you.
Thank you, ma'am, for the wonderful welcome and invitation. I first of all thank HOD of your department, Chemical Engineering Department, to invite me as a speaker for today's session. My PPT is visible, ma'am.
Yes, ma'am. It's visible, ma'am.
Is that full screen? Shall we start?
Yes, ma'am. You can start,
Yes.
ma'am.
Good afternoon to the students. Uh, Good afternoon, respected faculty fraternity of Chemical Engineering Department and the student friends who have gathered over here to hear the lecture. I'm very happy to share with you the topic, which is a topic for today, which is overview of petroleum refining and petrochemical processes. So, you are able to see the change in the slide. The slide is changing, ma'am.
No, ma'am.
No, no, there's a change, no, madam.
Yes, ma'am. Yes, ma'am. It's changing,
Yes,
ma'am.
yes, yes, yes. Thank you,
Ma'am,
thank you.
you can proceed, ma'am.
Yeah, yeah. Thank you. So, for today's session, we are going to study about the various processes involved in the petroleum refining and petrochemical industry. The reason why I have chosen the topic is that we need to ask chemical engineers. I hope all third years and final years are here. As chemical engineers, we should know what are the various processes involved in an industry and are we relevant? Are we studying relevantly? Okay. So to start with the lecture, the outline of the lecture for today is origin. We will be knowing from where does the oil and gas come from, and the exploration and production processes, and finally the various processes involved in the petroleum refining and petrochemical industry. So, so this is the crude oil. What you are seeing is going to be the crude oil. Basically, the crude oil is present in the reservoirs. It is we all know that the crude oil or petroleum is basically available from nature. So I have shown you the structure, chemistry of crude oil. So basically, the crude oil is made up of hydrocarbons, hydrogen and carbons, and the structure is being given over here. Like the molecules are made up of hydrogen atoms attached to the backbone of carbon. You can see this is going to be the carbon. Generally, carbon means it is coke, correct? Like we generally draw it in a black in color. So this is the backbone of the hydrocarbon called crude oil, and this is going to be a long chain hydrocarbon and very complex in nature. So this crude oil is what we basically obtain from the underground reservoirs onshore as well as offshore. We will be studying about how it will be, how it is originated. The crude oil, basically, it is called petroleum. Petroleum is um, oleum is oil and petrol is rock. Okay, so it is basically called as rock oil. Okay, the oil which is being produced from rocks. And there are various kinds of rocks, out of which sedimentary rocks contains this oil. And there are various theories which are being proposed in order to explain this origin of the petroleum formation, the petroleum origin and formation of petroleum. There are the theories basically proposed are organic theory, inorganic theory, and modern theory. There are so many people like astrologers, like geologists, scientists, researchers. Every one of them have come up with a theory on the origin of petroleum. Okay, so here I have given a few circumstances how the petroleum would have been produced. Okay, so I have given plants one side, plant plankton, and animal plankton on the other side. So so this microscopic plants and animals, what I'm giving you is with respect to ocean. With respect to the offshore, of course, in onshore, we know that this organic matter called animal, plant, and human beings, they this organic matter has been comes into contact. I mean, it is deposited under earth, and it is when it comes into contact with the high temperature and pressure, it is being transformed into oil. This organic matter is being transformed into oil. So this is this slide is with respect to the sea origin. Okay. Next, the plankton, from the plant plankton dies, and it goes to the seabed and forms an organic. I mean, it forms an organic deposit under the seabed, and the animals and the marine. I mean, the marine animals will like to feed on these particles, organic particles, and after some time they also they I mean everywhere they will die, and they get accumulated as an organic matter, and after which it has been transformed into oil, where the sediment contains the sediment, the organic sediment, which contains 5% of organic matter, and we call this as a black shale. We name it as a black shale, and this organic deposit, it is being deposited every time and gets compressed, and eventually forms a kind of rock. Okay, we call it as a sedimentary rock. Okay, as the black shale is going to be buried, okay, it is heated up, it gets heated up, okay, and then it is being transformed into kerogen, a substance called kerogen, and this is being transformed into hydrocarbon. Like this, all look at here. Here you have this oil part and the gas part, and this is the kerogen part. Okay, this is how the oil and the gas will be present in the sedimentary rocks. So this is with respect to the kilometer, okay, and that the various temperature ranges have been given. The organic matter. This slide basically explains how it is being transformed
Hello,
into.
ma'am.
Yes.
Ma'am, the slide is not moving.
Slide is not moving. Slide is moving, no? You are able to see the.
Yes, ma'am. Now it's changing.
Yeah, thank you. Okay. So the various substances, I mean the kerogen from the organic matter basically has been transformed into kerogen. This kerogen will be transformed into various forms. It will take various forms like solid, liquid, and gases at different temperatures, which have been mentioned here. Okay. So this indeed we call this liquid, we call it as oil, and the gas we call it as gas itself, like the natural gas basically. So the rock which has been producing the oil and gas, we call it as a source rock because that's a source for. We have been coined this name in order to understand it is a source rock which produces the oil and gas. Is that changing now? Exploration slide. Okay. I hope it is changing. Okay, exploration and production drilling is being explained in this one single slide. Okay, this is called the upstream processing. Okay, the upstream processing, like the petroleum operations, the petroleum processes and operations uh, uh, can be classified into upstream processing and downstream processing. Upstream processing is nothing but production of oil from the oil reservoir or the source rock to the land. Okay, though it is going to be an offshore or an onshore. Generally offshore is on the sea, onshore is on the land. Okay, when you produce the oil from the underground of the sea or on the land, we call it as an offshore production and onshore production respectively. And this process is basically called as exploration. Okay. So like how we do, there are various methods involved here in the exploration. Primary process, I mean primary oil recovery methods, secondary oil recovery methods, and tertiary oil recovery methods. Primary method is like how we do the bore, how we drill a bore in our home. Okay, in our houses, when you wanted to build a house, you will be boring. You will be doing a bore. I mean, you will be drilling a bore well to produce water. Correct. Similarly, we drill a well. Um, a well is being drilled to reach the oil reservoir. So we produce oil. It is called the primary process. Okay. Similarly, we will not be able to produce 100% of the oil. In the primary process, we will be able to produce only 10% of the oil. So next we will be sending another hole in order to send some drilling fluid. Okay, we will be sending some drilling fluid so that this drilling fluid will go and push the oil in the rock so that in the other well it's going to be a recovery. So that's how there are so many. Look at here, there are so many columns over here which are going to be the drill wells, like the rigs. Okay, these are the wells which have been drilled, and one drilling fluid will be passed, the other the oil is being produced. Okay, so that's how the oil is being produced, and this process is basically called as upstream processes. Okay, and then nowadays you have all the enhanced oil recovery techniques available in order to enhance the oil recovery, or to increase the oil recovery, because the primary processing will produce you only 10%, and the secondary processing where you use all the drilling fluids and all, sand, steam, or you will be using there's so many methods involved, so many types of drilling fluids have been involved here in the secondary processing, which is basically called as the secondary processing, which will produce somewhere around 40 percentage of the oil. Okay, and nowadays we go for the enhanced oil recovery methods in order to produce more oil, the remaining oil, because the 60% of the oil is still present in the rock, I mean in the reservoir. So nowadays we use all other techniques like gas flooding techniques. There are so many polymer flooding techniques, where in these techniques, various types of gases like CO2, like in the various polymers are being used as a drilling fluid in order to produce the oil, where we are able to produce somewhere around 25 to 30 percentage. So we are able to increase the oil percentage from 40 to around 60 to 70 percentage. Okay, So this is called upstream or exploration, or exploration and production by drilling the well. Okay. And you know something, the interesting fact is that like for drilling the well, the cost is really very high. It's an expensive process. Okay, they will be doing doing all the seismic analysis in order to find out whether the oil is present in the reservoir, in what kilometer it has been present, and then only they will drill. For every meter it has been drilled, they used to spend $10,000 for every meter. I'm telling you, for each meter. Then look at generally drills are being drilled for kilometers, so many kilometers. Okay, so think how it's going to be. Okay, then if they drill it, excuse me, you know, what is in here? I think I've changed the slide. So once the oil is being produced, okay, once the oil reaches the land, we call it as a field operation. It has come to the field, oil field, okay, and this need to be refined. Now we know the process called refining process. Okay, this refining process will yield you. Okay, this refining process will yield you what? All the products of petroleum refinery. What you all know very well. Okay, so this is the refining. When the slide is not moving, kindly tell me. Okay, okay. This is the crude oil which is being produced from the reservoir. Is basically desalted. Like let me move to the next slide so that you will better understand. Yeah, this slide, the previous slide. Okay, this is the crude oil uh, 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 which is being delivered from the oil well. Okay, and this crude oil is being desalted initially. This crude oil, when you look into the reservoir, basically this crude oil will be present inside the rocks, and the rock will be covered in the rock. Beside the oil you will find a lot of water. So when it is being explored and being produced, it will come out with water, with salts. Okay, so you need to remove those salts initially. So we will be doing a water wash in order to remove the salts, and this process is called desalting process. Okay, so it is called crude desalting. Generally what we will be doing is that we will be adding water, fresh water, we will be adding it with the crude oil, so that the crude oil will produce emulsions. Okay, oil and water emulsion, and water and oil emulsion. And then we will be applying high voltage to this particular crude oil, so that this water and oil emulsions will be breaking. Okay, we will be breaking all those emulsions in order to, so that we will be applying high voltage in order to break all these emulsions. So oil and water will be separated, and due to gravity, we will be separating oil and water. So while separating out the water, the salts will be going along with the water, so that we will be removing water as well as salts in this particular process. This is called desalting process. This is called preliminary process of processing of crude oil. Okay, before desalting, generally we used to do the sedimentation and settling. Okay, sedimentation and settling, because the crude oil, when it is being produced, you will find some mud particles, sand particles, okay, along with the crude oil. So which need to be removed. So the most primary process, okay, is going to be sedimentation and settling. The sedimentation and settling, you will be studying it in your mechanical operation subject. Okay, the various zones of sedimentation, etc. All right. So next is going to be the desalting, the settled, after removal of the sand particles, the solid particles, it has been taken to the desalting process, where you remove all the water with the salt. Salt is being completely removed. Then this crude oil is being now taken to the refining process. Okay, this refining process is nothing but distillation. Okay, distillation you will study, you will be studying distillation in the mass transfer subject. Okay, so distillation is a very important process in our industry. You know, I can tell you there are three important steps generally in the production of any particular chemical. Okay, you consider a sugar production or a paint production or any alkali production or anything else in chemical technology you would have studied. There are only three important steps involved. One is going to be reaction, next is separation and purification. Okay, so this once the reaction is over, separation is basically been done, mostly been done with the help of distillation in all our process industries. Okay, so this distillation, generally distillation, you will be studying binary distillation in your mass transfer. Okay, but this refining process is a multi-component distillation, very interesting process. Okay, because the crude oil contains multiple components, multiple products, so it has been taken to the fractionator for the fractionator. uh, so we will be naming the fractionator as atmospheric distillation unit and vacuum distillation unit, because the crude oil will be first fractionated in the atmospheric distillation unit, and secondly it is being it is again processed in a vacuum distillation unit, where we produce multiple products. Okay, which will, what are the products we are going to produce, we will study it in the next slide. Okay, so I'm emphasizing only the processes involved here. So the refining is going to be a distillation process, multi-component distillation process. Okay, distillation is basically a separation technology or a separation technique where we separate out the components in the feed, or in the raw material with respect to the boiling points. Okay, say for example, when you have benzene water system, in a benzene water system, we will be separating out benzene and water with respect to their boiling points. Okay, but then here, in your refining process, you don't have a boiling point. We'll be separating it separating the hydrocarbons or separating the products of refinery with the help of their boiling ranges. Okay. Mm, okay, they don't have a boiling point, significant boiling point, because when you consider lpg is a combination of butane and propane, not a single compound. It's a combination of compounds. Okay, so we will be doing that in the refining. So what basically we will be doing it in the refining is that we will be separating it out with the help of the boiling point. Okay, next is the reforming. The other processes involved are reforming processes. Okay, reforming processes are nothing but, which I have not mentioned here, the coking process. Probably this in the next slides you will better understand under the reforming process. Okay, one is a reforming process, the other one is a cracking process, the other one is a breaking process, coking process. All four important processes we will be doing it. Okay, these are the processes basically involved in a refinery. Okay, so this slide is the slide moving? Any one of you please answer. Is the
No,
slide
ma'am.
moving?
No, ma'am, not moving, ma'am.
Okay. No, my slide is moved, ma. Now you could see the distillation, separation by boiling point, no?
Yes, ma'am.
Hmm. Probably it takes a few minutes to, few seconds to get changed. All right. So this petroleum, look at this one, crude oil has been desalted and then taken to the furnace. Okay. Next is the furnace. It has been taken to the furnace because the desalted crude oil need to be heated to a very high temperature. Okay. So it need to be heated to a very high temperature. Then only it is being transformed into the various fractions in a fractionator. Okay. So you will be able to produce gases. Okay, gases from C1 to C4. Okay, so what do we basically do is that crude oil, I told you in the first slide, it is going to be a long chain hydrocarbon. Okay, you'll be breaking this, when you fractionate it, you will be producing simple hydrocarbons, like you will be producing different fractions out of it. Okay, like C1 to C4 fraction, you will be getting it as a gas, and C5 to C7, this is C7. Okay, it's not a question mark, it's C7. So C5 to C7 we will be able to produce, which we name it as a light naphtha. And C7 to C12 fraction, we will be calling it as a heavy naphtha, and then similarly kerosene, atmospheric gas oil, residum, all these things. So this is going to be your atmospheric distillation column, where we will be able to produce all these fractions. Okay, these products we will be able to produce in the atmospheric distillation unit. Okay, look at here. This is also the similar picture. Okay, this is the industry view of a refinery. Okay, and this is the plant. I mean, where the crude oil is being taken to the furnace, where heated up, where you produce gases at 20 degrees Celsius. The previous slide was in degree Fahrenheit. Now this is in degree Celsius, so it is more relevant to us and can imagine. Okay? Gases are being C1 to C4. Gases are being produced at 20 degrees Celsius and 150 degrees Celsius. Between 20 to 150 degrees Celsius, we will be able to produce a fraction called gasoline. Okay, which is used as a car fuel. We all know it is named as petrol. We call it as a petrol. Okay, and between your 150 to 200 degrees Celsius, we will be able to produce a fraction called kerosene, which is being refined again to produce yield you jet fuel. Okay, jet fuel is being used in jets. Okay, uh, uh, planes or flights. Okay, and then between 200 to 300 degrees Celsius. Okay, that's why I told you it's boiling ranges. It's not boiling point. Okay, these fractions have been produced. I mean, the crude oil is being fractionated with respect to the boiling ranges, because gasoline has got a boiling range, kerosene has got a boiling range. Okay, there is a range. Okay, from this range to the next range. Okay, basically, but other substances, they have got boiling point. Okay, so that's a difference. And between 200 to 300 degrees Celsius, we produce diesel oil, and between 300 to 370, we produce fuel oil. And finally, it's still heated up. We will be able to produce lubricating oil, paraffin wax, asphalt, etc., which have been used for road. Okay, all right. So the lube oil, we know the importance of lube oil. Okay, uh, paraffin wax is being used, and asphalt is nothing but tar. Okay, road tar. All right. I'm moving next slide. Okay, this also emphasize gives you the various processes, okay, involved in petroleum refineries. The LPG is nothing but the vapors. From the vapors C1 to C4 vapors, we produce LPG. LPG is a combination of your butane and propane. And next is going to be reforming process. Okay, where you produce naphtha, no, in your distillation unit. Naphtha is going to be one. You produce low heavy naphtha and light naphtha, and this naphtha is basically between C5 to C9. Okay, sometimes light naphtha we call it as between C5 to C7, and heavy naphtha we call it as between C7 to C9, and together it is called naphtha C5 to C9. It has been taken to reforming operation, where you produce. It has been, what is reforming? Reforming is something, without changing the molecule. I mean, without changing the number of carbon and number of hydrogen present in this naphtha hydrocarbon. Okay, without changing it, we will be changing the structure. Okay, you form it differently, you reform it. Okay, that's why it is called reforming. The naphtha has been reformed to produce gasoline. Okay, and we from the previous slide we already seen that kerosene is being used as a jet fuel. Already diesel is being it is fuel oil. You would have seen it as a fuel oil has been taken, has been refined to produce purified to produce diesel fuel. Okay, and gas oil is cracked. All right, and sometimes it's naphtha. That's why you have a stream from here. This naphtha has also been cracked. Okay, cracking is basically breaking of molecules. Like you have a long chain hydrocarbon, and with side chains also, sideways also, it has got complex chains, complex carbon and hydrogen bonds present. And when you break these bonds into smaller units, it is called breaking these molecules into small molecules. Okay, which is called cracking. Okay, this long chain will be cracked, broken into small pieces. It's like you have a long piece of paper cutting into different pieces. Okay, that's nothing but cracking process, where this cracking process will help us to produce motor gasoline, which is nothing but our petrol again. The same thing what we produce in reforming process. Okay, jet fuel we will be able to produce again. Diesel fuel will be able to produce during cracking, because cracking, it has been breaking into small molecules to produce all these compounds. Okay, we'll be able to produce all these. So after cracking, a part is being taken to the alkylation unit. This is going to be another process. Okay, like I'll tell you, this is reforming is going to be one process. The first process what we saw is distillation, and nextly we saw it is going to be reforming process, and thirdly it is cracking process, and now it has come. We have come to the alkylation process. Alkylation is something like combining an alkyl group, okay, to the cracked molecule. A small molecule is being added with that of the alkyl group to produce the LPG and gasoline, okay, which means LPG and petrol. Okay, and now after the bottom stream of the alkyl, or the residuum of alkylation unit is being cooked, and even this residuum is being combined over here. Okay, they are being cooked properly. Cooking is nothing but taking the material into high temperature. Okay, I mean treating this residuum, all residues, treating it to a very high temperature in a furnace. Cooking basically happens, and this will produce you industrial. This has been used as an industrial fuel. This will produce a lot of energy. Okay, which has been produced, which has been used for fuel applications. Okay, energy applications. Okay, and then of course all these LPG, gasoline, jet fuel, all these products of this petroleum refinery, of course they are being used for energy applications. They only provide us energy. Okay, they produce energy and we are using it. Okay, for all LPG is being used for domestic purposes. Petrol and diesel are being used for transportation purposes. Okay, and the jet fuel, again, transportation purposes. Okay, and this industry, this has been used directly as industrial fuel. Asphalt, wax, lube oil, which has not been mentioned here. They have been refined. They have been again purified in order to use. In order to use it as a final product. Okay, whereas asphalt is nothing but your tar, which has been used for road pavement and other insulation purposes. Okay, so this is these are the processes basically involved. I can tell you the primary process is called this distillation. Okay, this is the primary process of any refinery is going to be a distillation, which covers your atmospheric distillation unit and vacuum distillation unit. When you distill the crude oil, when you fractionate the crude oil in the atmospheric pressure, we call it as an atmospheric distillation unit. Okay, and when the atmospheric residue, the bottommost product, whatever you produce from atmospheric residue, is being again fractionated under vacuum conditions. Okay, then it is called vacuum distillation unit. Both together are the primary processes of any refinery, and the secondary processes are going to be reforming, cracking, alkylation, and coking. These are the secondary processes. Of course, we have the finishing processes, which are called the purification process. Okay, generally purification processes are going to be hydro treatment processes, like hydro desulfurization processes, hydro treatment processes, hydro fining processes, or hydro finishing processes. Okay, so which is going to be the tertiary processes. These are the processes basically involved in any refinery. So look at the chemistry involved. Okay, this chemistry part involved in the cracking, alkylation, polymerization, reforming, and isomerization. Even the other process involves isomerization. Okay, there are so many other processes which are also been involved. Okay, dehydrogenation, isomerization, okay, cyclization. During rearrangement or during reforming, all these things will happen. Okay, correct. So cracking is nothing but I told you is breaking of molecules. So look at this big molecule C7, H15, C15, H30. So it's such a big chain, long chain molecule. It's been broken into gasoline additives, and going to be another big compound which has been again going for a recycle. Okay, so this is to make you understand. I've given you this slide. So alkylation, you add an alkyl group here to another molecule. Okay, to another broken molecule from cracking process, so that you will be able to produce propane. Okay, um, propane, and then other compounds also. Okay, next, polymerization. Okay, polymerization We all know that any monomer is being polymerized in order to produce you a polymer process. Okay. So, and reforming processes, reforming, isomerization, all these happen during the rearrangement of like reforming operations, basically. Okay. So, all these will happen during your rearrangement process or conversion reactions. Okay. So again, the same slide has been given in a different form. This slide I have included in order to make you understand there are tertiary processes, okay, which are going to be hydro treatment processes, and these hydro treatment processes involves hydrogen. Okay, so what is this basically? This hydro treating processes. Hydro treating processes are nothing but any product you produce, it's been treated with the hydrogen. Like you produce gasoline, it has been treated with hydrogen. Naphtha you produce, it has been treated with hydrogen. So you may ask me a question, ma'am, why do you want to treat it with hydrogen? Okay, hydrogen is going to be a very interesting compound, which will, and the first compound of your periodic table, which would like to make friends. Okay, which will combine, which will get along with any compound easily. Okay, that is why refinery basically involves this hydro treating processes as finishing processes. Okay, so hydro treatment is nothing but, let us say you have your product, fuel gas or a gasoline is being accompanying, I mean sulfur compounds. Sulfur is considered to be an impurity. Okay, nitrogen is nitrogen, sulfur, oxygen. All these are found to be impurities present with these refinery products. Now it is our duty as a chemical engineer to remove all these things. So removal is basically done with hydro treatment processes. Okay, so when you wanted to when you hydro treat your product, gasoline product. Okay, look at here. Light naphtha has been hydrotreated to produce your gasoline, where this light naphtha, okay, which is C5 to C7, which will have all these sulfur compounds, let us say, okay, and even nitrogen compounds. Now this hydrogen will go and combine with sulfur to produce your hydrogen sulfide, which can be easily removed, and or even the hydrogen will be combining with sulfur dioxide or sulfur trioxide to produce you sulfuric acid, which can be easily removed, so that you will be able to produce a pure gasoline. Okay, according to the norms. All right, according to the according to the quality testing, like a good quality the gasoline can be produced here. Okay, similarly, you want to produce aromatics, you produce diesel fuel. Okay, then this hydrogen will combined with nitrogen to produce you HNO3 and nitrogen and oxygen, and will combine easily with oxygen to produce you water. Okay, all these can be easily removed. Okay, so that is the reason why we go for hydro treatment methods. These hydro treatment methods are called the tertiary or the finishing operations of any reforming. So once hydro treatment is over, now this is the tertiary process I'm telling you. So far what we have studied is the primary processes involved in any refinery is going to be the distillation, atmospheric distillation and vacuum distillation. Okay, and the secondary processing methods are going to be reforming process, cracking process, alkylation process, coking process, where reforming will have uh, will will involve the chemistry such as dehydrogenation, cyclization, like you will have isomerization. All these will be under will come under your reforming processes. Okay, all this chemistry will be involved in reforming processes. Okay, and finally, the tertiary processes are hydro treatment processes. Okay, so where you will be able to, we will be able to produce we produce fuel gases. Okay, which is nothing but your LPG. Okay, even natural gas will be able to produce gasoline. Okay, aromatics are nothing but benzene, toluene, xylene, ethyl benzene. Okay, and then jet fuels or kerosene we will be able to produce, diesel and fuel oils we will produce, and finally we produce, we also produce vacuum gas oils. Okay, and which are being again cracked with the help of a catalyst. Cracking process is being done for a vacuum gas oil. You look at here, this is a complete picture. Okay, you have the atmospheric distillation unit, you have the vacuum distillation unit here. Okay, where this residue I told you, the residue of the atmospheric distillation unit is being processed in the vacuum distillation unit to produce you vacuum gas oil, lubricating oil, asphalt, and the residue is being coke to produce you coke. It is been will undergo a coking process to produce you coke. Okay, so now this vacuum gas oil has been catalytically cracked in order to produce again diesel and fuel oils. Okay, so lube oil has been processed to get a pure version of lube oil. Okay, and asphalt has been processed, air blowed in order to air blowing process has been basically performed in order to reduce the viscosity, in order to increase the stability and increase the consistency of tar or asphalt or bitumen. It is also called bitumen. In order to give way to, in order to ease the road pavement and all. Okay, so these are basically the processes involved in petroleum refining. Sorry, this petroleum refining. And now, till last slide, what we studied is going to be the refinery or refining industry. Okay, the processes involved in the in refining industry. Now we will study what is called a petrochemical industry and what are the feedstocks involved for a petrochemical industry and what are going to be the products we are going to produce in a petrochemical industry. Okay, so far what we studied is going to be refining industry, petroleum refinery. Okay, can anyone name some? Can anyone tell me the name of the refineries? What you know? Can anyone tell me few names of the refineries? Students, you are able to hear me? Yes, you are able to hear me?
Yes, ma'am.
Yeah, you are able to hear me, no? So I just asked the question. So
Can you
CPCL,
unmute them?
yeah. Oh, you are muted them. Okay, okay, okay then, no problem, madam, no problem. Okay. So let's continue then. So the processes involved in any refinery, we studied the primary processes, secondary processes, and the tertiary processes. And now we will do the petrochemical industry. Okay, petrochemical industry is going to be the next industry. Okay, which cater all our needs. Okay, the basically the feedstock used in for a petrochemical industry is naphtha and gas oil, and the gas fractions, the various gas fractions, whatever we produce from crude oil, from a refinery. So the refinery product is being used as a feedstock here for any petrochemical industry. And even the natural gas what we obtain from a reservoir is being directly can directly be used as a feedstock for petrochemical industry. So, what is the importance of petrochemical industry? Is that, like, look at here, the refinery is utilizing crude oil as a feedstock where you produce multiple products, and these products called naphtha, kerosene, even some of the other oils, okay, LPG, they have been used, they have been processed in another industry called petrochemical industry in order to produce light olefins. Light olefins are nothing but ethylene, propylene, butylenes, butadienes, and then we produce benzene, toluene, xylene, which are nothing but your aromatics, and we also produce linear alkyl benzene, which are your detergents. The other chemicals like styrene, terephthalic acid, intermediates, okay, etc. Hydrogen and some few papa energy also we will be deriving it there. Okay, so this is all about petrochemical industry. Okay, so this petrochemicals can be classified into first generation, second generation, and third generation petrochemicals. Okay, the first generation petrochemicals are nothing but they're also called building blocks. Okay, and they have been obtained from crude oil, natural gas, naphtha, and gas oil. Okay, basically from naphtha and gas oil, because naphtha and gas oil is being produced from crude oil. Okay, so the examples for for first generation petrochemicals, how do we do it? How do we produce and what process is being involved here when crude oil or naphtha or gas oil is being used as a feedstock? Okay, when these have been used as a feedstock, they'll undergo cracking process. Okay, they will undergo cracking, which is nothing but breaking long chain is being broken into small molecules. Long molecule is being one molecule is being broken into small molecules to produce you ethylene. I mean the lighter end, which are called ethylene, propylene, butylenes, and butadiene and BTX. Okay, and now second generation, the next classification of petrochemicals. Second generation, they are also called they are also called intermediates. They are produced from this ethylene, propylene, butylenes, butadiene, and benzene, toluene, aromatics. Okay, say for example, from ethylene we produce styrene. Okay, dimethyl terephthalate. Dimethyl terephthalate we produce from ethylene. Okay, terephthalic. Similarly, terephthalic acid, vinyl chloride monomer. Okay, adipic acid. All these things we produce from ethylene, propylene, butylenes, and benzene toluene xylenes. Okay, combination of all these things will yield you these compounds. I've just given you simple examples here. And the third generation petrochemicals are nothing but the plastics, fibers, and rubbers. Okay, the third generation petrochemicals, in order to produce third generation petrochemicals, second generation petrochemicals will act as a feedstock now. Okay, like how your first generation petrochemicals like ethylene, propylene, butylene are used as a raw material in order to produce second generation. Similarly, these second generation petrochemicals will act as a feed in order to produce a third generation. Say, for example, like terephthalic acid and DMT. Okay, they have been used in order to produce plastics. Your PET bottles, polyethylene terephthalate. Okay? Like similarly, Similarly, fibers, rubbers, okay, they are being produced from the second generation petrochemicals, pesticides, insecticides. I just mentioned few pesticides. So many other chemicals, electronic chemicals. Nowadays we use chips and other things. Every material is made up of every material comes under the third generation petrochemicals. Okay, and they are going to be the commodity products. So we can always call these as consumer commodities, the third generation petrochemicals. Okay, so the process or the mother unit involved in any petrochemical industry, I told you, the process basically is called a cracking process. Okay, cracking process. You may ask me, I mean, distillation. I told you in petroleum refineries, it happens. The process involved is distillation, where you study that distillation properly in mass transfer. Okay, what about this cracking and all? Cracking is again, cracking is nothing but heating the particular raw material to a very high temperature. When this naphtha, let us say the crude oil or naphtha, distillation of crude oil will produce you naphtha. This naphtha, when it undergoes, when it comes into contact at very high temperature, which means it has been burnt at a very high temperature. It has been broken into pieces, like it has been done in a furnace. Cracking is basically happened. It basically is being done in a furnace. Probably these are the temperatures where light naphtha has been produced, heavy naphtha has been produced. But this naphtha produced will undergo a temperature called 800 to 900 degrees Celsius, so that at that particular very high temperature, it will be broken to produce you. It will be cracked to produce you first generation petrochemicals such as olefins, which are your ethylene, propylene, butylenes, butadiene, and aromatics, benzene, toluene, xylene, and higher aromatics, which are your first generation petrochemicals. Okay, so cracking is basically done with the help of steam. Okay, and we call this as a mother unit, because why do we call it as a mother unit? Is that the mother? The first generation petrochemicals. This will be acting as a feed to the second generation, and second generation will be used as a raw material for the production of third generation. That's the reason why this naphtha cracker process or a gas oil cracker process, when the cracking process may involve gas oil also. Okay, so cracker unit, any cracker unit involving naphtha or gas oil, we could basically call it as mother unit of any petrochemical industry, because that's where we produce a very basic first generation petrochemicals. So you produce from naphtha in the cracking using in a cracker. Okay, in a cracking process, you produce ethylene. Okay, from this ethylene we produce ethyl glycol. This is monoethylene glycol, diethylene glycol, triethylene glycol, ethylene dichloride, vinyl chloride monomer. From vinyl chloride monomer, this vinyl chloride monomer is being polymerized to give you polyvinyl chloride, which basically is a third generation petrochemical. And this ethylene, whatever you produce, is being polymerized to produce you PE. PE is nothing but polyethylene. And propylene, whatever you produce here in the naphtha cracking process, is being polymerized to give you polypropylene. You produce butadiene directly from naphtha cracking process. You also produce aromatics. Okay. And what is this LDP and HDP? LDP is low density polyethylene, high density polyethylene. All are various versions. Okay. These are various versions of polyethylene. Okay. So next is the chemistry. What I'm giving you, it's the cracking process. Look at this. This is naphtha. Naphthas, I told you, is C5. In between the green color part is a carbon, and these are the hydrogen part, hydrocarbon. This is the long chain hydrocarbon. This naphtha at very high temperature, called 800 to 900 degrees Celsius. That's why we call it as a thermal cracking. Thermal cracking undergoes thermal cracking to produce your free radicals. Basically, we call it as a free radical mechanism. The chemistry involved in this particular naphtha cracking process is going to be free radical mechanism, where we will be producing the lighter compounds, where we will be producing ethylene, propylene, etc. So, any free radical mechanism has got three stages, correct? Which you would have studied very well in your chemistry: initiation, propagation, and termination. So, this is the initiation step. This is the propagation step, where free radicals will be produced, and free radicals will be rearranged in order to, or reorganized in order to produce you the whole small molecule, which is nothing but ethylene, propylene, etc. Okay, so this is these are the three important stages of the free radical mechanism, the chemistry behind your naphtha cracking or thermal cracking process. And these are the process parameters involved in the naphtha cracking process. Look at the flow diagram here. Look at the flow diagram. This flow diagram will help you understand how the naphtha cracking is basically being done. Okay, this naphtha is being this is the furnace part. It's been undergoing higher temperature. I told you cracking is basically done in a furnace. Okay, it will where the cracking basically happens here, which is mean breaking into small molecules happen here. So this is called pyrolysis. The other name for the process called cracking is pyrolysis. This and then next, when the pyrolysis is over, what do you basically obtain? You obtain ethylene, propylene. Like you will not produce methane or methylene. Okay, you produce ethylene. The second compound C2, C3 is propylene, butylenes, okay, C4 and butadiene, okay, and then you produce benzene toluene xylene. So all together you will be able to have it as a product of this furnace. Okay, so you obtain here, and now it has been quenched in a quench tower, cooling, quenching, cooling, chilling, all have been done. And next is that it has been taken to a demethanizer unit, okay, where you produce, we will be able to recover all the fuel gas, hydrogen, etc., which means the much less compound, light compound, much lighter compound is being taken out from here in the demethanizer unit. And then the bottom product, the remaining things, I mean, out of the products, out of all the products, you remove only this fuel gas and hydrogen as a top product, and the bottoms of the demethanizer is being taken to the de-ethanizer unit. Okay, in the de-ethanizer you produce acetylene and ethylene, and this acetylene is again hydrogenated to produce the ethylene. So you produce ethylene. That is how you produce ethylene. See here, that is how you produce ethylene. Okay, and then in the de-ethanizer, the remaining thing, I mean, after removing ethylene and acetylene alone, the bottom, I mean, the remaining products, I mean, the remaining product profile, products involved in the product stream is being taken to the depropanizer unit. And in this depropanizer unit, we will be removing your, again you will be removing a little more ethylene compound or acetylene compound, okay, where we produce, and propylene also we will produce. Okay, we will be taking it as a, we will hydrogenate this, every fraction we will hydrogenate and take it in the form of, I mean, convert it or transform it in the form of propylene. So this is how you produce propylene here. So you produce ethylene, you produce propylene, and then from depropanizer unit, the bottoms have been taken to the debutanizer unit, from where this in the debutanizer unit we produce butadiene, okay, and then the bottom product is being fractionated in order to produce you by benzene toluene xylene. Okay, and even look at here, the C4s to butadiene, which means butylenes and butadiene is being extracted here, or it is being recovered here. So what are these processes? These processes are the fractionation processes. Okay, these processes are called your fractionation processes, which means your distillation again. Okay, so see how important, how thorough it is for us to study all the separation processes involved in the mass transfer. Okay, so this pyrolysis is again furnace. Okay, it's all about furnace. I don't know whether you have a subject called combustion and furnace design, where this subject called combustion and furnace design will help you in understanding more about this pyrolysis or cracking, uh, cracking operations. Okay, and this is called, this is, I mean, now here, I mean, once the pyrolysis is over from the furnace, we will be doing all this chilling compression, which is nothing but heat exchanging. Okay, heat exchangers, where we heat exchanger design is very important, and heat exchangers will study from the subject called heat transfer. Okay, so there, from here also, you have a fractionation columns. Okay, you have fractionation columns which in which you will be doing fractionation as well as heat exchange. Okay, and you have compression columns here, compression trains, you have chilling trains where heat exchanger again. Okay, so this demethanizer, deethanizer, depropanizer, butanizer, and all these are going to be the distillation columns, and these are the hydrogenation units, which are nothing but the separation fractionation units or distillation units, and splitter units. Okay, so these together, covers the processes of heat transfer subject and mass transfer subject. Okay, move on to the next slide, where it gives you the product profile. You produce hydrogen, methane, you get some very minimum quantity of methane, ethylene, ethane, ethylene, you will get minimum quantity of ethane, propane, and all. But then our aim is to produce ethylene, propylene, butadiene, other butylenes, and heavy products are nothing but aromatics. Okay, and even gasoline, in terms aromatics in terms of gasoline. And this is the first generation petrochemical ethylene. From first generation petrochemical, we produce all these compounds. Polyethylenes. Polyethylenes are, you will find polyethylenes everywhere around you. Polythene bags, ethyl benzene, styrene, PVC. You will get polyvinyl chloride pipes. Okay, everywhere we use only this for pipes. Vinyl acetate, polyvinyl acetate, more polyvinyl acetates, is been polymerized. You get acrylonitrile, ethanol amines, glycols, ethylene glycol, polyesters, which are nothing but polyethylene terephthalate. You know, ethylene butadiene rubber. Rubber, you produce a kind of rubber here. Okay, SBR, you produce styrene butadiene rubber. Okay. So next is propylene, the product from propylene or polypropylene mainly, cumene, polystyrene, you produce acrylic, acrylonitrile, other fibers. Okay, acrylic fibers you would have heard. Okay, epichlorohydrin. Now all these compounds we will be able to produce. Okay, and each and every compound of these, okay, has got various applications. All right, you produce benzene, toluene, xylene from petrochemical industry. Okay. Mm, and the separation techniques involved here are going to be, the processes involved are going to be distillation, okay, extraction, crystallization, and absorption. All these you come across all these in the mass transfer subject. Okay, so so I'm not here to teach you what is liquid extraction. I just wanted to show you these. I mean, these processes have been involved in petrochemical and petroleum refineries. Okay, and the chemicals from benzene, toluene have been given here. The various chemicals from benzene, various chemicals from toluene. You know, xylene, paraxylene is going to be the very important raw material for the production of polyethylene, polyesters, polyethylene terephthalate PET bottles. Okay, and apart from which we produce resins, films, pigments, nylon. We produce nylon. Okay, some of the insecticides, fungicides have been produced from xylenes. Okay, so that's about the various processes and the products involved from the products we produce from petrochemical and petroleum refineries. Any questions? Any questions, students? Any questions? Anyone?
The session is open to the questions.
Okay, as there are no questions, I take this opportunity to thank your respected HOD and the other faculty members, and specifically Ms. Nadachi, who's my own student, PG student. I express my sincere thanks to each and every one of the faculty and the students who are very patient enough to listen to the lecture. Thank you, one and all.
Thank you, ma'am. Thank you so much for your wonderful lecture. I like to thank you for your valuable time and effort to deliver the lecture, ma'am. I would
Thanks a
also
lot.
thank you, Dr. A. Brinda Lakshmi, Department of Chemical Engineering, for taking great effort to make this event happen. Thank you so much, ma'am.
Thanks a lot, ma'am. Thank you. Can I leave the meeting, ma'am?
Yes, ma'am. Thank you, ma'am.
Yeah. Thank you, students.